Welcome to the Chorus One podcast. In this podcast, we explore the emerging open financial system facilitated by scalable, interoperable blockchain networks. Tune in every Monday to dive deep into cutting-edge projects and protocols with Chorus One team members and guests.
Hello. Today we have a very special episode for you. I am catching up with Ryan Park. I met Ryan while the Chorus team was traveling in South Korea. We took part in a hackathon organized by the Cosmos team, the Seoul Hackatom. And Ryan and his team made a brilliant iteration, a radical iteration on the staking module of the Cosmos Hub. And they created a new asset which is called bAtoms. And so I'm going to converse today with Ryan about their hackathon entry and how they see the staking module of the hub and other blockchain networks evolve in the future. Ryan, welcome to the Chorus podcast.
Hi, thanks for the welcome. I'm Ryan. I'm currently working as a team member at a company called Ellipti. We're currently developing the idea Meher just introduced you about. It's called bAtoms, and for an extension, Everett.
So Ryan, you're still studying in university as well, right? What do you study there?
It gets a bit complicated. Our school isn't actually a university. It's a type of a special school. But I used to enroll in physics and chemistry. And I got my background mostly in physics. I also studied a bit in mathematics and the theoretical parts.
And how did you get involved in the cryptocurrencies ecosystem?
I wasn't around in blockchain for that long. My first encounter of Bitcoin was at around 2014. I think I was in middle school back then, but I didn't give a lot of interest. So back in 2017, I first heard about Ethereum, and it really excited me to know of a new technology like that. So since then, I was researching about different kinds of blockchains and consensus protocols. And right now, I'm currently doing mostly researches on DeFi protocols.
Cool. So in the Seoul Hackathon, your team, which is the non-say team, it won the first place. And I'm curious about how this team was formed and what you built in the hackathon.
Our team members, they were all living at a place called Nonce. It's a blockchain co-working and co-living space. It's in Seoul. And if any of the viewers have a plan to visit Seoul someday, be sure to contact Nonce. It's not an advertisement, but it's a really cool place. You should pay a visit sometime. So I was just at Nonce, just throwing ideas to people. And one of them was to create like a staking derivative. And some other guy just came up and told me that there was a hackathon coming up, the Cosmos Hackatom. And we just decided to go out, to test the idea, and test our developmental skills. That's how it started. So for the team members, the main team members, there are three. Obviously, there's me, the other guy is called Jaewon, Jake, and there's Jongwan, who's our developer, very talented. He knows Cosmos very well.
And so your idea is a staking derivatives idea, right? So tell us about the particular derivative you built in the hackathon.
So our idea is called bAtoms, which is short for bonded atoms. What was included in our initial idea was that pretty much all proof-of-stake blockchains have a critical problem so that the central interest rate distorts the market ecosystem there. So the idea was to have a secondary token called bAtoms that is one-to-one price peg to atoms, and it uses the staked atoms in the Cosmos Hub as collateral to back the price.
Yeah, so my understanding of bAtoms is, I think bAtoms solve two problems. The first problem I could perceive before I had gone to the Seoul Hackatom. Mm-hmm. But what I find really interesting about the non-say entry in Seoul is it made me aware of the second problem. And the second problem is even more like maybe fundamental than the first problem. So the first problem, of course, is a very bread and butter problem, for me at least, is when I delegate to a validator on the Cosmos Hub, all my atoms are locked today. I cannot do anything else with them. Now, if I look at like the Cosmos ecosystem, lots of people are building very interesting zones. You have Kava that's building a stable coin. Lots of interesting zones coming up. My question to myself is, I want to use the functionality of these zones, but to use the functionality of these zones, I usually need to put up an asset, right? So for Kava, I need to put an asset up and get a stable coin out. My main asset in the Cosmos ecosystem is atoms. And today those atoms are sitting on the hub just locked up, right? So as a participant in the Cosmos ecosystem, how will I be able to actually make use of these zones? I don't see a way around today, right? So bAtoms solves that problem, and we'll get into how it solves that. But the really fascinating second problem, which the non-say entry, I was made aware of this problem only by non-say entry, is the problem that derives from the setting of a central interest rate on the Cosmos Hub. So could you explain this problem, and could you explain the Austrian economic thinking that goes behind this problem?
I have to first start with the Austrian business cycle theory. If you haven't heard of it, it's a very well-known theory in Austrian economics. So the concept of that theory basically states that the interest rate set by the central bank in an economy would distort investments in the market, which will create distortions in the business cycle. So to give an example, let's say the Federal Reserve has set this year's interest rate to 5%. That means if you just put your money in a bank, then you'll be receiving 5% per year just by putting your money there. So in an economy, you have two choices with your money for investments. You can just put it in a bank and get the interest from it, or you could look up a investment product by yourself and directly invest in those products. So there's always a trade-off there. You can only pick one of them. You cannot do both of them at once. So that's the trade-off there. And logically, in this example, if the investment product you found offers less than 5% a year, but by profit-wise, it's illogical to put your money there. You'll get more money out if you just put your money in a bank. So naturally, investment products that offer less than 5% per year in the economy would lose competitiveness. So this also applies very well to Cosmos as well. So currently, if you stake your atoms, if you delegate your atoms to a validator on the Cosmos Hub, you'll get around 11% per year. So this basically means in the future, when there's like Uniswap on Cosmos or Compound.finance on Cosmos that offers shared fees to people who provide liquidity, basically investment products on the Cosmos Hub, if those products or protocols or applications offer less than 11% per year, then atom holders won't be putting their money into them. But there has to be supply in order for demand to arise. But the current 11% interest rate given out in the hub, it will distort the ecosystem there, especially the DeFi ecosystem. So that's the problem we found, and that's the problem we wanted to assess.
Yes. And this problem is pretty fundamental and it's fascinating, right? The problem is like this. So if you look at Ethereum today, on Ethereum, you have a lot of protocols where you can lend your Ether, right? So you have Compound where you can go and lend Ether and you can make interest. You can lend it on a host of these new protocols like DYDX, Compound, etc. Now, when one goes to the Compound website, you see that the interest rate on Ether is very low. It's around 1% or even less. Now, assume like Compound could also accept atoms, right? And maybe like atoms will be like Ether. They'll only pay a 1% interest rate in Compound. So today when I own Ether, it makes sense for me to go and put my Ether into Compound and make that 1% Ether interest. But it's not going to make sense for me to take my free atoms, my non-delegated atoms, put it into Compound and make 1%. What that means is if you think of a protocol like Compound, it is a good match with Ether. Ether holders can use Compound and Compound can offer a product to Ether holders. But it's not a good match for the free atom today. Compound cannot provide a competitive product for atom holders, and atom holders won't be able to use Compound. And so the universe of opportunities, of DeFi opportunities for free atom holders is naturally restricted by the interest rate of the Cosmos Hub.
Yeah, that's correct.
And yeah, it does feel like a fundamental problem. And then tell us about how you solved this problem in the Hackatom.
So our idea to the solution was quite simple. Obviously, the problem arises because you cannot receive delegation rewards and the shared fees from investing in an application. You cannot do that both at once. So that is a problem. So by allowing delegators to do those things at once, then the problem will be solved. So basically receiving delegation rewards and shared fees from protocols doing those things at once. So our solution was to create a secondary token that has a one-to-one price peg. The token, we called it bAtoms, short for bonded atoms. Bonded atoms or bAtoms will have a one-to-one price peg to atoms by design. And it's collateralized. It's backed by the atoms that are staked. So, for example, if a delegator delegates 100 atoms to a validator, and in the bAtom zone, if he or she delegates those 100 atoms using the bAtom zone, then 10% of those 100 atoms will be kept as collateral in case of slashing, and the other 90, they will be backing the newly issued 90 bAtoms, which exist in the bAtom zone and will be given back to the initial delegator. So what a delegator could do is to first open up a delegation position on the Cosmos Hub and create bAtoms from that, and use those bAtoms to invest in protocols like Uniswap or open up a position on Kava, so that he or she could both get the shared fees and the delegation rewards. So that was our idea.
So today the normal delegation is I delegate and my atoms are locked. The system you implemented would have me delegate 100 atoms, and then as soon as I delegate 100 atoms, 10 atoms out of those 100 are sort of locked.
Yep.
And the rest of the 90 atoms are used as collateral to print another token, which is like the bAtom. And the bAtom is liquid and you can do things with it.
Mm-hmm.
Most importantly, you can take the bAtom and you can put them at work into protocols like Kava. And because the hub has 0% interest for the bAtom, you can use it for DeFi, and all DeFi protocols will be competitive with the bAtom as the underlying asset.
Yes, what we are hoping for.
Okay, so I delegate and I get the bAtom, and then there's this second part, which is like the 10 atoms that are put up as collateral to cover for the validator slashing. Right?
Yep.
So today, if a validator gets slashed, they can lose 5%. So if I delegate 100 atoms and 10 atoms are put as collateral and the validator gets slashed, well, 50% of that collateral can be destroyed. So these 10 atoms are like very risky. Do you have a name for these 10 atoms, this risky piece?
Unfortunately, we don't right now. If any of the viewers have any suggestions, we're happy to get those, but we don't have a name for it yet.
So in some sense, this is like the responsible asset, you know?
Yes, that's the asset in risk.
Yeah, so that's the responsible asset, and then the bAtom is like the free asset or like the free token, and this is the responsible asset. So in your implementation, do you also issue another token on top of the responsible asset, something that represents the responsible asset? So I do a delegation, right?
Okay.
And what you explained is when I do a delegation, I get 90 bAtoms.
Yes.
Can you make an implementation in which I get 90 bAtoms and like 10 responsible atoms for the validator? I get 2 tokens, not just 1. Or is your idea that I get a single token?
So it's a bit similar to MakerDAO in some sense. So if you open up a CDP in MakerDAO, you put in Ether and you receive DAI out of it. The Ether you put in, it's still owned by you, but you don't have immediate access to it. You cannot transfer it, you cannot sell it, or you don't have immediate access, but it's still owned by you. It's a bit similar to that. The delegated atoms are still owned by you, but you do not have immediate access. The same goes for the 10% part collateral. It is still owned by yourself, but it's just locked there.
It's just locked away. Okay. So now these bAtoms, what's the use case for these bAtoms? Like, is it just to power DeFi, or why would I want to hold bAtoms?
So initially that was one of our critical problems. Unlike, for example, like DAI, bAtoms didn't have a utility. So there was no reason to buy bAtoms if you could just buy atoms instead. So after the hackathon, we had to come up with a initial use case for bAtoms. So what we thought of is like a lending protocol between tokens among different Cosmos zones, so that if you look at like different Cosmos validators in the hub, they're also willing to become a validator of other Cosmos zones, but they have to acquire additional funding every time they become validators of additional zones. So instead of doing that, we're currently thinking about creating a lending protocol so that validators could convert their self-bonded atoms into bAtoms and then use that as collateral to receive a loan of tokens from other Cosmos zones to use to become validators on other Cosmos zones as well without acquiring additional funding. So that's one of the use cases we thought of. And to get additional demand in those protocols, bAtoms could be used to settle interest rates in those. But in the long term, we hope that bAtoms would be used as the wrapped ether of Cosmos, where protocols, especially DeFi, would use bAtoms instead of atoms.
Yeah, very interesting. So, of course, in the hackathon, you implemented bAtoms as a native feature of the hub.
Mm-hmm.
It was a showcase that the hub could be upgraded to have this new kind of delegation logic,
Yep.
in which you delegate and you get 90% as bAtoms and 10% remains there to cover for slashing. But it feels like a very radical change for the hub.
Yeah, that is true.
And to get such a change through governance is going to be an uphill task because it is so radical.
Mm-hmm.
So, do you have a solution to implementing bAtoms without the hub needing to upgrade in such a radical fashion?
So we need a technology that creates addresses that are on the Cosmos hub that is controlled by zones, and it also has to be flexible enough to be used. The problem here is that because the validator sets in the zone could be changed, we cannot just use a simple multi-sig trick in that. So in the hackathon, we created a special module called Staking IBC module to solve that problem. But obviously that has to be implemented, that has to be passed. A hub upgrade is required in order to use that. So we're currently looking into other options like multi-party computation or threshold signatures, those options, but we are yet to have a perfect solution for it yet.
Okay. So you're thinking of now implementing bAtoms as part of some zone where instead of this being a native feature of the hub, people will be able to bring atoms over to your zone and then they'll be able to delegate their atoms in the zone and create bAtoms in the zone.
Yes, that is true.
That seems like a very ambitious project.
I believe pretty much all startups are. They have to be ambitious.
Yeah. So, are you going to pursue this as a commercial venture with Ellipti, or are you going to fundraise on such a zone?
Right now, a commercial venture would be quite preferable. Maybe a bit of fundraising would also help as well, because honestly, one of the biggest problems in developing this idea to a product would obviously be security. There has to be a lot of auditing in the incentive systems and also the code as well. But unfortunately for Cosmos, there is not a lot of service providers in those sense. So those kind of problems have to be solved. And we believe it's great to have this as a commercial product.
Cool. It was great to chat with you, Ryan. I'm really fascinated about this bAtom solution. To me, personally, the thing that fascinates me about bAtoms is, can the bAtoms be used as a staking token in a different zone? So Suppose you generate bAtoms on the hub or wherever, and now they flow onto region, and then bAtom holders are able to stake in region using the bAtom.
I also considered that before, but I am also yet to have a conclusion on that.
Yeah.
But that will also be quite interesting as well.
I think the fundamental idea of being able to delegate and have some kind of token which can be put to further uses and which doesn't need to earn 11% interest. I think identification of that problem, I think, is the valuable piece of Non-Say Team's Seoul Hackathon entry. And I was delighted to see this entry because it made me think differently.
Thanks for your compliments.
Cool. So how can listeners follow your project or get in touch with you or read up about your entry?
So we are currently developing a website to introduce the project. The project name is Everett, Everett. If you look it up, our website name will be everett.zone. And the reason we call it Everett, if you look it up, if you Google it, Everett's one of the guys that came up with the multiverse theory. I mean, we're basically making another Cosmos atom based on the base Cosmos atom, so it's like a multiverse. So that's the reason we chose to call it Everett.
I wasn't aware of this. So if I recall it correctly, this has to do with quantum mechanics. So
Yes.
in quantum mechanics, the traditional interpretation of quantum mechanics is the Copenhagen interpretation, where reality becomes real when you observe it, right? So when there's a quantum system, it's not real, but when an observer observes it, the quantum system becomes real and presents some properties to the observer.
Schrodinger's cat.
Yeah, this is like the collapse of the wave function. So there's the Copenhagen, that's the standard interpretation. But in 1953, I think Everett came up with the multi-world interpretation of quantum mechanics, in which basically the universe is continuously branching off into multiple child universes. And it's like a tree of universes. And every time you observe a quantum system, you force the universe to split into two. And those two universes will go down different paths. So every observation forces the universe to split off into its own branch. I think that's the Everett multi-worlds interpretation.
Yeah, that's the reason behind the name being Everett.
That's an interesting name as well. So it was nice to catch up with you, Ryan, and I hope to have you back on the Chorus podcast someday when Project Everett is further along.
Cool. It was awesome to be in the podcast as well. Thanks for your time.
Thank you for listening to the Chorus One podcast. Visit chorus.one for more information about our work. Don't forget to subscribe to the podcast to stay tuned on new episodes airing every Monday.